right, this video is section 6.4 and we're going to be discussing exponential functions. Exponential function is usually written in this format: y equals a b to the x power, where a is not at 0, b is not 1, and b must be greater than 0. Generally, we just simply say it's a nonlinear function that changes by equal factors over equal intervals. And there's a reason why I've got this highlighted, factors, and I'll show you that in just a moment. So let's go ahead and kind of show you what the difference is between an exponential function and a linear function. A linear function is just like what we already know. It's a straight line. It makes a straight line. An exponential function is a little bit different. It starts off and it keeps going straight, and it seems like it's going, but after a certain point, it just skyrockets. All right? And that's literally what an exponential function does. It starts off kind of slow, and then at a certain point, it just goes up exponentially and goes very, very fast. And what this looks like on a graph, not a graph, but a table, is something like this. So a linear function, we have the x values, 0, 1, 2, 3, 4. This is a constant rate right here of plus 1, plus 1, plus 1. It's changing in the x values by plus 1. And then if we look at the y values, it's a plus 2, plus 2, plus 2. We know this to be our slope. We know this to be our constant rate of change. So if we were to write this as a slope, it would basically be 2 over 1 or just 2. However, an exponential function is something different. The x value is constant, all right? It's a constant change. It could be a plus 1, like just in this example I have given to you. However, the other variable is also a change, but it's not an addition or subtraction change, it's a multiplication. Notice this, 4 to 8 is not just a plus 4, it's a multiplied by 2. This is a multiplication by 2. This to this is a multiplication by 2. So if you ever get a table where the x values are consistent with the pluses, but your y values aren't unless you do it into multiplication, this is when you see an exponential function. It's doubling. So let's start looking at some exponential functions. Can't say the word. So it's telling me to evaluate the function. Y is equal to 4 to the x power if x is 2. So basically all I'm doing is plugging 2 in the place of x. So y is going to be 4 to the second power. Well, we basically can plug this into a calculator, or we already know that this is 4 squared, then y is just simply 16. Nothing overly complicated on that one. So let's try something that's a little bit more tougher. It says f of x is 2.5 times 10 to the x power. So, and it's telling me that x is 4. So we're going to plug 4 everywhere we see x. So f of 4 is equal to 2.5 times 10 to the 4th power. Well, let's just use our calculator on that because it'll make our life a little bit easier. I'll put it over here, get it out so we can see it better. We're going to say 2.5 parentheses 10 all to the 4th power. That 10 is to the 4th power. Plug it in and we get 25,000. So f of 4 is equal to 25,000. Why don't you try 3 and 4 on your own and see how you do? So you should have got that for number 3, f of 5 is equal to 8. For number 4, y is equal to negative 686. This one may have stumped you. You may have got a positive number or whatever by accident. I just want to walk you through it. Negative 2, then you would put your parentheses 7, and then this is going to be raised to the 3rd power. If we were to follow our PEMDAS rules, please excuse my dear Aunt Sally, what is actually being raised by this exponent is the 7, not the 2, but the 7. So this gets raised first, 7 to the 3rd power, and then we multiply it by the negative 2. So that's 7 to the 3rd power, whoops, cleared it out, 7 to the 3rd power, and then we multiply that by the negative 2, if we follow PEMDAS, okay? All right, now, Number 5, it says graph the function, describe the domain and the range. All right, so this is going to get a little bit complicated, especially if we try to do this by hand. But the best thing for us to do is to basically create a chart. I'm going to say X and I'm going to say Y, okay? So what we're going to do is we're basically going to plug any number we can think of in the place of X. Since I have, looks like I'm counting by ones here, so let's see what happens and we'll use ones. I'm going to do, let's do -3, we'll do -1, I'll do 0, 1, and 3. Why did I pick those numbers? Well, why not? The reason why I did pick the negatives because I just want to see if anything will be on this side. After I've picked the numbers that I'm going to use, I'm basically going to plug these numbers into the calculator and see what happens. So I'm going to say 3 times 0.5 raised to the -3rd power gives me 24. Then we're going to do the next one, 3 to the times 0.5 raised to the -1 gives me 6. Then we're going to go 3 times 0.5 raised to the 0 power gives me 3. Then we're going to go 3 times 0.5 raised to the 1st power gives me 1.5. Then we have 3 times 0.5 raised to the 3rd power gives me 0.375. So let's just go back through all these. I had 24. I'll write it down. I had 24. Then there was 6, followed by 3, followed 1.5, and then this number is 0.375. So we can kind of we can see what that is as a fraction by hitting the math button and going to fraction, and it gives me 3/8. All right, so we can take this information here and actually plot it on here, so we can do the best that we can. We're going to pretend that this is counting by ones, so this will be 1, 2, 3, and since we have a number that goes up to 24, let's see, 6, 12, 18, 24. So we're going to count by 6 on our y-axis. All right. So we're going to count by 6 on our y-axis. Now that we've got our numbers, let's plug things in. So the first one was -3, 24. So -3, 24 would be here. The next one would be -1 and 6, which would be right about here. The next one would be 0 and 3, which would be here. The next one would be 1 and 1.5, which we're going to do an estimate to the best of our ability, which looks like this. And then lastly, we have 3 and 3/8, which we're going to do our best again to look something like that. And if we were to draw this and try to draw a line, it's going to look something to this nature. And this is not perfect because I'm human and so are you, but it does give us that exponential function, that curve. So this is what it tends to look like. Now, it tells me to do one more thing. It says to describe the domain and the range. Well, recall back from previous chapters, the domain represents our x values. Well, our x values, our domain here is going to be all real numbers. Why is that? Well, if you look, this line, if we continue to travel, it's going to continue going all the way to the right. And if we did this, it's continually going to go all the way up into the left. It's never going to stop. It will never go vertical, but it will always continue to go slightly to the left. So the domain is all real numbers. But what about the range? Well, this one's a little bit difficult because look at what happens. If we were to continue this pattern and start plugging numbers in, I want to show you something. This is where we're going to use our calculator. It's going to be really, really interesting. I'm going to go y equals, and I'm going to plug this equation in. 3 times 0.5 raised to the x power. All right? And I'm going to set up my, clear that back out. After I set this up, I'm going to hit the table button. All right, look what happens here. This is literally the same table that I just made, all right? Literally everything. So negative is 3 and 24, just like we did. Then we have negative 1 and 6, just like you see here. Then we can go down. We have 0 and 3. Then we have 1 and 1.5. And then we have 3 and that 0.375. Now look what happens. The farther I go away in my x value, I keep going positive. Look at this number right here. I'm getting farther and farther, and it keeps getting closer and closer to the number 0. But the truth is, I never reach 0. I never come close to 0. I get really, 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 really close, but I never touch it. All right, I get close, but I never become 0. What that means is that it's actually saying that y is greater than 0. I can get all the y's from here and up, but I can never reach 0. And I can keep going and looking at it, and I can keep going until infinity. And even though this gives me a scientific notation number, it still never reaches 0. It looks like it, but it doesn't. Not mathematically anyway. So the domain is all real numbers. It can be any number in the world, but the range can be anything greater than 0, but it cannot be 0. So let's look at number 6 together. So this time, we're going to graph this, but this time let's be a little bit lazy and actually use our calculator. This time I want to show you what I did. So I'm going to plug this in. Negative, let's put this all together. I'm going to put negative 1/3 in there as my fraction, and I'm going to multiply that by 3 raised to the x power. And now I'm going to hit graph. See what it looks like. Ooh, gives me something weird. So I've got something that's going this direction and then goes down. All right, so we have that concept, but what are these numbers? Well, the best thing for me to do is to go to our table. So I can hit second table. And this gives me a table, and I'm going to scroll all the way back up to 0 here just so you can see it. This gives me a bunch of different numbers. It gives me my x values and their corresponding y. So let's look at it from here. So right off the get-go, if we looked at -3, it gets us 0.0123. And if I continue to go down my negatives, it's getting closer and closer to 0, but it never touches 0. It's still in the negatives. It never becomes 0. So that gives us that. Now let's look at where x is 0. Well, when x is 0, it says it's 1/3, and then when 1, and so forth and so on. We can actually graph this. So what we're going to do is, according to this, 4 is 27. So let's count. Let's see if we can count by something. Let's count by 9s maybe. 9, 18, 27. Yeah. So this will be -9, -18, -27. And we'll count these by 1. So let's plot what we possibly can on this teeny tiny thing. So 0 and 1/3 would be somewhere right like there, give or take. Then the next one would be, according to our numbers, I'm going to come over here so you can have both on the screen. Our next one would be 1 and -1. So 1 and -1 would be somewhere like that. The next one would be 2 and -3, which would be something like this. The next one would be 3 and -9, which would be here. The next one would be 4 and -27, which would be here. So if we were to graph this to the best of our ability by hand, it would look something to this nature. Let me get this out of my way. Something like that, all right? And which matches up with our graph, what we saw. And we have a straight line, and then it just plummets down. All right, so we've graphed it. We've used our table to do that. I cheated by using the calculator, which is something I suggest y'all doing. So make sure you kind of go back and watch the video to see how I did that. So let's just talk about the domain. Well, the domain is easy. It's all real numbers again, because this number continues to go to the negatives. This number will continue to go in the x values in the positive. So it's going to be all real numbers, okay? Then my range. Well, my range, look at this one. It never touches 0, but it's always less than 0. So my range is that y is going to be always less than 0. Okay? All right. Let's talk about 7. The number of visits y to a new website quadruples every day. The function y equals 12 times 4 to the power of x represents the number of visits, where x is the day. Graph the function. Well, I'm going to be lazy again, and I'm going to use my handy-dandy calculator because it's my best friend. 12 times 4 to the x power. I am going to do my table first and see what happens. So, according to this, 0, I have 12. So look at this. This is at 3,000, so I can't even hardly plot that. At 1, I have 48. I barely plot that. At 2, I have 192, which I might be able to get somewhere like there. Then at 3, I have 768, which might be right about here. And then at 4, I finally get around 3,000, so I can put that there. And my 5th day, I'm at 12,000, here it is, 12,288, somewhere around there. So, if I were to graph this, here we go. This is what this function would somewhat look like to the best of our ability. Now, we've graphed it. Describe the domain and range. Well, the domain, here's the thing about that. Is the domain in this really all real numbers? We know this line can continue going in this direction, but does that make sense? This is the number of days. Can we really go back in time to -1 days if we start at 0? No. So in this particular case, our range is that x is going to be greater than or equal to 0. And we can kind of prove that thought because when we look at this, at 0 days, we have 12 people. 12 people have seen our site on the zero day, all right? And then we really can't, and if we start going back to -1, well, this seems somewhat plausible. But then we go into this. How is that possible? How can I go back -2 days and get 0.75 of a person, 0.1875 of a person, 0.04 of a person? So in this particular case, the domain is contextual. It means that I can't really go back because this is in days. It doesn't make sense. The domain has to be greater than or equal to 0. So what about our range? Well, according to this, our range is going to be greater than 0. All right, so y is greater than 0. How come it's not 0, excuse me, not 0, but in this case, it's going to be 12. I'm sorry. Why is that? Well, think about it. If our domain starts at 0, that means that our range must start at 12. That goes back to it. So it's saying that before anyone ever looked at it, 12 people were there. Well, how is that possible? How are 12 people there if no one's ever seen it before? Well, think of it from this standpoint. Maybe those 12 were the people who created it in the first place. All right, so that's how come that number may exist. All right, so the domain for this would be, just to rehash, is all numbers greater than or equal to 0, and while the range is all numbers greater than or equal to 12. Sorry, I forgot to put that symbol there. All right. Now it says how many visitors did the website have on the 3rd day? Well, that's easy. We got that in the calculator. All we got to do is scroll down and look at it. So x is 3, so we have 768 people. That one was easy. So really, the big takeaway is that if you haven't figured it out, this is your friend during these functions. This is a very useful skill for you to have, even more so than what you've had before, because it deals with numbers that are going to be very, very large and will grow very, very quickly. And that's it for this video. It's been a little bit longer than I expected, but that's all right. And I'll see you in the next one. Bye-bye.